All right, we'll begin for the evening. There are not an ideal number of people here yet. However, we need to get started. We'll run out of time for at least the C-sharp portion. Announcement overall for both sections, JavaScript and C-sharp included. We will for sure be moving locations in April. So we'll no longer be in this location here at the Sprint Accelerator. We'll be moving to another location. I will let you know as soon as I'm aware of what that location is, where we're going to. I currently don't know where it is. I know there are a bunch of different options, but rather than share all the possible options with you and have you be disappointed, I'm not going to share any of the options. And you'll get a nice surprise, hopefully by Thursday, if not Monday of next week. But April, we will be in a different location.
What's the last day of class?
Question was, what's the last day of class? The last day of class session is April 13th. And then there is plans, I think I'm supposed to share this, but not, that's too bad, for a Unit 4, which isn't technically an extension of this class, but it is an extra month that you are all welcome to go to. Catherine will send out more information, but it is an extra month, so you all have more guidance and help for preparing for the apprenticeship. So we'll finish these 3 units. April 13th is the last official day of this class, and then there will be a thing being done in Unit 4. And that will have more help. There'll be more hands-on. We'll finish the class, and then you'll have that month have people help you sort of figure out what project you can work on, or if you're trying to do a project, they can help you get ideas there, or if you're running into issues you can't quite figure out on your own. There's going to be an extra month called Unit 4. Also at a location I don't know that you can get help. April 13th, official last day of fall LC101. LC KC fall 101. LC101 KC fall, you can switch it around. All right, now looking towards just the C-sharp portion, you have an assignment that is due Thursday, this Thursday, Tech Jobs MVC, which is short for Model View Controller, of which you will have no models in your Model View Controller for Tech Jobs MVC. You won't have for real models. You'll have kind of models. And for everyone else to be aware, on Monday, Tom is being kind enough to take my position while I am away. I'll be out next Monday, but Tom will be up here instead of me, helping out. That was 1 week from today. All right, we can begin on the starter questions. Jonathan, your group does not look large. I'm gonna fix the microphone.
All right, so just to start off with, do you have any questions about the material this week?
Does this sound good? No. All right, fix it.
So before my hearings, last week I talked a little bit about overlay. This week is more about overriding. I'll start with overriding. What is this? What is overriding the method?
Virtual based class. And then pass interference from the predefined by size. And like we change the class. So basically, change that method actually works.
Right. Based on the declared method is going to override virtual. And then in the derived class, subclass, specify the overriding. So So an example of that is two-string. If you look at the definition of a two-string method in the documentation, you'll see that the virtual keyword is used for the definition of that method. And we mentioned the serial case, you see it in the documentation for the MS Microsoft Office. And you get that for the definition right there. So talk a little bit about requirements for that. We have there's the method virtual base class, and then the drive class is right. Are there any requirements for drive?
Yeah, so it makes sense. It's the same thing.
That's the same name. Yeah, it's the same types. The parameters. That's all the same signature. Same markets, same type. So that's yeah, so you want to provide your own behavior for a method that's already being used in the class. Good example is two-string. So then you have an object. You're writing a class, you might want to provide a better with that class. Stuff. Yeah. So going back to inheritance, let's talk about base classes. Base classes. Base classes. Same thing. How would you declare a class to be a subclass? Yeah, so class already break down colon is the name of base class. And so that will give you the public, all the accessible members of that class.
That is
Big complicated and then we'll do some classes. So you have to worry about all the details. Just in general, everything that's accessible, you have access to the drive class. And so you can reuse behavior. This one of the purposes. How about how would you declare a class that allows subclasses to share behavior does not allow you to use handshake for your class?
You have 8 more minutes, just so everyone knows.
Abstract. Yeah, if you declare the class abstract, you're saying anything that derives from that class will have certain behaviors that it has to be used in the child class. So you also have abstract methods. It's you don't declare defining behavior. You're just saying this is the contract that all the subclasses need to do, and then all the subclasses have to use the behavior. So how about if you want to access a method in the superclass from your derived class? Yeah. If for some reason maybe your maybe there's shadow. Basically, you're getting base access to numbers and shading. So that's what. Let's see what else. How about class diagrams? We have a solid line between two entities in the class diagram. What does that represent? It represents inheritance. think that it's like one student has one grade, has one training. Exactly, yeah. So it does, that defines a one relationship. And the example that we gave was a two grade. How about class diagram? Yeah, so a transcript can have many grades. You can draw of course, records align up to the transcript for the open time. Reports or something. Great. And what is the purpose of this class diagram?
Plan out all your code before you start jumping in.
Yeah, for planning purposes, also to communicate your ideas. So if you want to talk to the other people about what you're planning to do, plan to present to somebody like this. Your coworkers or manager, each role what you're intending to do. And then later, like what is after hearing this, see how close you're to that plan or things that you gain from this class diagram. It's a way to communicate with yourself for planning purposes. Final class diagram relationship with the material was just a line and arrow. That's the appearance, yes. So you can specify the example of the was at base class and then the arrow from the house back up to that base class diagram relationship. I think that covers it. You're making simply, I really never know. I'll provide I'm going to follow this is actually I also think so. I think the process,
Oh, you're good. Keep going.
Actually, I'm going to need some information about how you're doing the screen caps. That's one thing that I think you do have time to do it next time. So maybe Thursdays.
Yeah, I can do it. Let's start a Thursday how I normally do it.
Okay. Is it pretty straightforward?
There's probably a more straightforward way to do it. I go through like 6 links on YouTube. It's the only pathway I know how to get to it.
Okay. Is there anything I need to install on my computer?
It might require an extension. It's not an extension. I use Chrome, so it may be baked in. Actually, because I'm using Chrome, maybe why it doesn't ask for it. Because it is casting this whole other screen.
Yeah.
So I think it's doing that because of this Chrome. It has access.
Okay, yeah, so what I told you is basically it's
You can see all the stuff in all these classes the same things. So I guess it would be the same.
Product, yeah. So if you start using the increase for project line, that's a question. Actually, I'll post
All right. Wait. Yep. So fortunately or unfortunately, depending on your point of view, C# is going to get started because I have a good deal of code to cover for this evening, and it would be a great disappointment to myself if we don't cover it all, largely just due to the time it took to write it, selfishly. So brief overview of what I plan to cover, unless you specifically post some extra bits inside of the Hello KC channel. I'm going to follow through in the order of the following. I'm going to open the source code for .NET Core that we're using directly. I'm going to open that and show you the object class, which is the class all of our classes inherit from, so that you can actually see how simple the language is set up and where you can go if you're reading the documentation and it's not that useful or you're having trouble. You can go look at the source code of the framework itself. I plug the TV on in the back because I'm going to be covering a lot of code. And I'm also sorry from a presenting standpoint that I have been forgetting to alternate this color to be a white background, which is better for people viewing at a long distance. I'm sorry, I've been failing you for weeks. So we'll cover object. I will then show a simple case of overriding a superclass in your subclass. So for the controller, specifically, it relates to one of the recommendations in the prep material. And then finally, we're going to have a possible solution to the restaurant studio that was last week. But my solution to that studio is actually going to cover all of the stuff that you learned for today. So it's a pretty large set of classes and implementation, which is why I've also put the link to the code itself in the Slack channel if you want to go directly to it and view it while we cover it, because it is a lot of code, and I'll try not to jump around too much. I have much more detailed notes than I normally do about the order I should flow through the material. All right, so we will start with looking at object first. The purpose of looking at object here is to show what it is that allows overriding of class methods. So right here, we can see defined in the source code of C#. It's available on GitHub because they've open sourced it, which is a nice feature of the language now. Was not that case 2 years ago. So now you can actually go in and look at the source code. For me, it's actually a little easier. So Python, it's a little bit difficult to look at its source code. It is publicly available, but it is not stored on GitHub, so it's not as easy to view. Oh, it is on GitHub. Oh, they have a mirror. Yeah, awesome. So Python set up a GitHub mirror. So you can look at Python source code as well. But for the C#, what I wanted to show you is that they define the object class. You can ignore some of the keywords and some of these other tags. You'll see some more esoteric things when you look directly into the source code of a language, because it is sort of the fundamental building blocks of how it works. The main piece I wanted to show, so we're inside the object class. The main bit I wanted to show is how toString works and equals, and how there are multiple versions of equals that you get for free. The key word that is mandatory for a subclass to override behavior of its parent class. So if you have your house cat trying to override the behavior of cat, cat must declare its method as virtual. If you do not declare your method as virtual, a subclass cannot override it. And this is where C# deviates actually from a lot of other programming languages. I actually kind of like it compared to other languages I've used because it makes it very explicit allowed to do. So that public virtual string toString is why every single object you can override and have your own toString. And then down here we have equals, which, as I mentioned, goes and builds in immediately. You have an equals so you can override. And then there's actually an equals that is static, which means you'd have to say object.equals when you were using it, not your class instance, but the actual class object. And the difference here is this method is not virtual, so it cannot be overridden. But these first two, which we've covered so far as methods to override, toString and equals are both fairly simple. Even their implementation is fairly simple. getType, that is just a method that returns the type definition of your class. So if you were to create a class, student class, the type definition is that it is student type. So in this case, it returns that it is object type, which isn't all that useful. but it automatically works in your subclasses, and it will get the name. And I'll actually show you a little bit of this getting overridden in the code later. But then that toString calls toString, as you would expect, and returns a string.
So it's calling toString there. Is it calling itself? Or is it calling?
So get type. So get type there is returning an object that it is then calling toString. It's returning an object of some variation. Main thing I wanted to show is that toString and equals, two methods you'll likely override often in different classes you write. The implementation is pretty easy to follow once you have an idea of how it's implemented in the language itself. And I also like to show how accessible it can be to go and look at pieces of the language directly, if you want to get a better understanding of how certain parts work. So the next part I want to cover is using that overriding. So this will be an MVC app, much like we've been using. All I did was run the .NET new MVC command. It went and generated out, as you can see, some controllers and some views. What I want to show you first are the 3 views. So you can, for the most part, ignore the view data part. We haven't covered what that does, but that's what gets generated by default when you tell it to go spit out a whole new app. What you can see here is we're doing viewbag.name and viewbag.message, and then we have an area that is specific to the about page. And then in contact, we do something very similar in this view as well. We do viewbag.name, viewbag.message, and then something specific to the contact page. And our index page, which is the slash, so the home page, doesn't do anything special, just does viewbag.name and viewbag.message. And for whatever reason, I chose to format it differently. Not on one line in this one. That doesn't really matter. So to show, so to show what this looks like, we can start it up. At port 5000. This is just to show what's happening. So we're on the index page, that home page, index, a shared message, about. So that changed. We still have a shared message. And then contact says contact, and we still have a shared message. The way this is all accomplished is by overriding a method. So what I'm doing in this example is specifically what one of the prep materials recommended. It's for trying out how you might, on every rendering of a page, override what occurs. That's a terrible noise. Overrides what occurs on each render. So we only have one controller. So for every action on this controller that renders, we've overridden the view method so that we can have shared behavior between each one of those pages on that controller. So what we have on the index is we go and set the name to index, set the name to about, and set the name to contact. And that's why in each one of these, about, viewbag.name, .name, .name. That is why in contact, about, and index, a different name on each one of those pages. Now, if you notice, in none of these three methods, index, about, or contact, we are not setting the message. That message is getting set down here in the view. So we override the built-in view method that exists on controller, the class we are inheriting from, so our parent class. And we set the message, which is why a shared message exists on all three of those pages. Because the view method, we're calling it in all three of our actions on our controller. And then the bit that makes this work, entirely render a page, go to the right template, and insert all the variables, are because we call base.view. Base is a reference to your immediate parent. So if I say base.view, that then calls the view method on the controller class. So we have the controller class that we're inheriting from. So anywhere in here that we call base, that is a reference to the controller class. Are there any questions on how this works before we get into the restaurant menu items example? Because it will build on these principles and ideas, but it will do a lot more. I wanted to give you all a much more realistic example than we have gotten to date with a solution. Video and example code that is more akin to something you would actually write or use in the wild. I will assume the lack of hands means you are excited to go and look at the restaurant. Is this zoomed in enough? Does anyone need this zoomed in a little more? I should have asked that already.
Yeah, just.
All right, zoomed in a wee bit more. And sorry if my scrolling messes anyone up. I had to change my scroll settings. There's various different laptops that I use. We're using different ones, and that was causing me all kinds of problems. There's also, I linked the TV in the back. So if that's easier to see, you're welcome to look at that one. All right, I will make this, actually, rather than continue to run code in there, I'm going to zoom this in. I'm going to execute all the commands to run the restaurant program in a different window, mainly because it is difficult to see. Keep scrolling up and down. Well, I don't know how to change the colors of this quickly. So you get to live with the dark color here. So just to show what this program does, it does what the menu item stuff was supposed to do. I want to show you first what the program does so you can have an idea of what is in it. It takes a moment to start. So what this goes and does is there's a restaurant called My Place. It is located at 42 Wallaby Way, Sydney. And then it has a nice little description. It's the best place to eat. Period, period. It is a lunch menu. And then it breaks it down into appetizers, prints out the appetizers, the entrees, prints those out. Much like anything else I've created, you might see duplicates. Other parts might change each time you run it. That's largely just because I don't like to manually create data. I'm lazy. So it's randomly generating data every time. We'll go over the generators at the end if there's time. There's not really much going on in that class, but I separated out the generation of data this time how I wanted to last Thursday, but ran out of time. So separated it out beforehand so you can sort of see how that code separation would look. So we have appetizers, entrees, sides, and then desserts. And if you notice, some items are tagged with new, much like they would be one of the requirements we were given. I didn't put legend on here largely because of time. So then right down here, it says we've been around for some time. That is the history of the restaurant, sort of what would normally be on the back side of the menu. And it's always nice when your program tells you that it's done rather than just sitting there. So at the bottom of the screen, you may not be able to see it. It says done, press enter to exit. So I pressed enter to exit. And it exited, printed out the menu for the restaurant. Are there any questions on the functionality before we dive into the code? All right. Well, just to make sure we're all on the same page. So the requirements for it, so there would be several menu items. As you saw, there were several. We would have a description, a price, and a category. You don't see a description because I didn't want to clutter up what got printed out. You'll see it in the code. It's there. I just default to an empty string. That's why nothing's getting printed out. I don't want to have to worry about making sure the description matched the randomly generated name. So I didn't do it. You can think of the name being the description. There's categories for each one. We can display whether or not it's new. And you can't see it in the printed version of the menu, but I will show you how we are keeping track of when the menu was last updated and when each menu item is updated. And you can probably assume there are constructors for each class, otherwise nothing would have printed out. There is a way to add and remove items from the menu. However, I'm not doing it currently because I didn't want to bother with that on the command line. If I do another example of this, I'll make it more on the web portion, so then there will be a remove add in the web UI. Same for the menu item. We know when it's last updated. And as you saw, there's a way to print out the menu item in the entire menu. You see it all there. You don't see a design of the classes, partially because I'm lazy, and the other reason being it's not that common to go and create all the UML class diagrams that you would have read about, or you might read about on Thursday, but I think that was in this Monday reading. So the class diagrams, you don't really need to worry about them, for being honest. If you implement your classes, there are a load of tools on the internet that you can click create UML diagram and it will create them for you. So if you can think about your classes, write them out, you can just write out stubs, no implementation, and then it can go and generate your diagrams for you behind the scenes. It is important, however, to understand a lot of that terminology that is used in those class diagrams. So the restaurant has a menu. The menu has many menu items. Those words, has a and has many, are very important to understand what they mean when people talk about the relationship between classes. So in the case here, we have a restaurant class, a menu class, and a menu item class. And before opening them, restaurant has a menu, menu has many menu items. If you notice, I have a base class up here. All of my classes, restaurant is a base, menu is a base, and menu item is a base. That is a means that it is an instance of that class, or it inherits from that class. So in all of the classes we're going to use inherit from this base class. And that is on purpose so that we can share behavior in all of our classes. So the first class we're going to go over is base class. So right here, so the namespace of our application is restaurant. And this is a public class, base class. I call the base class because it's what all of our other classes are going to inherit from. What this declares is a constructor that takes no arguments, and it sets the ID to what is called a GUID, a globally unique identifier. So we can hover over that. There's a GUID class built into C#. That is handy, and it will generate globally unique IDs. This returns a new instance of it, and then we make it a string. The odds of collision are somewhere around like 1 in 20 trillion when you go to generate any two IDs. It's very low odds they will ever collide. So a lot of software systems, rather than using auto-incrementing IDs, as you've seen so far, where we've said 1, plus plus, then we get 2, plus plus, we get 3, and we keep going. A more realistic example of what people will use for two reasons. One, GUIDs are more likely to be unique across different databases and across just systems in general. The other reason is from a security standpoint. If you have a website that is /user/ID and they're auto-incrementing, people can keep hitting each one of those IDs to try and figure out what they might be able to do to a specific user. So if they found a vulnerability in your website and you use auto-incrementing IDs, they can just start at the first ID and keep going until there are no more to keep attacking all of your users. Whereas if you use these GUIDs, they generate, you'll see it in a minute, very long strings that are incomprehensible for just guessing. And then the other thing that happens in this base class is we make a created date. And that was one of the needs for knowing whenever menu items may be new or when the menu may be new, is we know when we create the menu and the menu items. Because now everything's inheriting from this, there is a created attribute. And if you notice, it's automatically getting set to datetime.utc now. In almost all cases of writing software, you should use UTC now. You should keep all the time to store in your database in UTC, which is Universal Time Code. So locally here, we use Central Time. You want to store your data in Universal Time. The reason for that
is oftentimes, when you go to a website, it might be in a different time zone when you're viewing it, and it will show to you when you made an update in that local time. The reason it can usually do that is it's storing it in a unified format, which is UTC. That also makes it safe to compare dates across different parts of your application. So if you wanted to check when a menu item was added to when a menu was created, you can compare them safely. But if you were not storing UTC now, and you were just allowing the user or whoever's calling this class to pass in any date time they wanted, when you compare them, you're not necessarily guaranteed to be comparing the same time zone of data. So you may not actually be properly comparing. That's why on a number of websites, that might be off by an hour, depending on if it's daylight savings time or not. Nothing else out of my little spiel there. Always use universal time date. Things so that ID and created that we set, because we have declared private on our setters, because they're properties, ID and created are both properties, they are private, subclasses cannot override the ID or the created date. That is on purpose, because once the ID is assigned, that object is not allowed to change its ID. And it's also not allowed to change when it was created, because it was created when you made a new instance. I then made a helper function here, for the most part, called identity. The reason I made this is so I could see what was happening between all of my different superclasses and subclasses and see what's occurring there. So I'll do another .NET run just to show you where I'm using that identity before I talk over what those are doing. It says press a thing if you're done. If you actually hit other characters, it goes and prints out all this other bonus information. This is printing out each one of our objects that exist. That's what I'm using that identity for, and that's why I built it into the base class, so I could know when I print any object in our program, they could have a sort of unified format. So I made a method that they all inherit. Now, if you notice, there is no virtual set on this, so subclasses cannot change it. They can only use it. So what's occurring here, so the first thing we print out is the restaurant, next we print out the menu, and then we print out all the menu items. The first thing that's getting printed out there is the namespace that the object exists in. So for in our case, it's restaurant is the namespace. And then it prints out the name of the object. So restaurant, menu, menu item. And then next up is that GUID that I was talking about. So the ID, those IDs are all random every single time that we rerun this program, because we're not storing it in between program runs. But that is what the GUID looks like by default. So it's a very long string of random characters. And then it goes and prints out created, so we can see when each one is created. I'm having it print out to the hundredth of a microsecond, so you can actually see differences in the time. Otherwise, you wouldn't be able to see them. I had to go out that far, and otherwise it wouldn't show the differences. You can see here, so that's 749, 750, all the way down. You can see they're actually getting created in different microseconds. And you can also see that they're getting updated. So this ends at 750351, 750355. So this menu item was updated after it was created. I haven't shown you yet how it's achieving doing that, but I wanted to show you how that identity helper method works. So that when we talk through it here, it doesn't seem like complete nonsense. So if you noticed in the source code for object, it called a method called getType. So getType returns what is referred to as a type object, and it has a namespace attribute and a name attribute. That's how I'm getting the namespace it's in and the name of the object. So you can see here it returns a type object, and a type object has the namespace and name properties on it. And then finally, the ID gets put in. That's just a property on the class. Then the word created, and then it puts in our created property, as well as the updated property. Then I went and had to Google around and finally look at the docs for how to get into format. So just like in Python and in JavaScript, if you've written, and really most languages, whenever you write string interpolation in any way, so anytime you're writing strings that can sort of have any value put in them, you can then pass a format to it. So the way that syntax in C#, this is a better example that I've shown in other classes. So you can do this colon, and then you give the entire format. So in this case, it's the 4-digit year, 2-digit month, 2-digit day, 2-digit hour, 2-digit minute, 2-digit second, hyphen, 100th of a microsecond. Which was actually pretty cool. It's been harder in other languages for me to find the ability to print out the microseconds. So it was nice here. So last two things to mention. So we have a private updated, which all that's happening here, and the reason that it's made private, I made set do nothing. That is humorous. So we have an updated attribute that goes and gets it, and it doesn't actually directly set it to anything. And that's because I have this method down here that is forcing you to use UTC now. You don't get a choice with this base class. And even if you did somehow manage to go in and change it, it's explicitly saying to universal time and always returning the universal time of the date. Which here converts the current date time object to coordinated universal time. So the updated attribute has a getter and setter. Setter does nothing. And that is because we actually have a public method called update made. You can think of better names. In ORMs, normally this is something that would happen when you save the data. It would go and automatically update the updated time. We're not using a model yet, so that's why I created this update made. And anytime you go and make an update to your class, you should call this update made method. There are magical ways in C# to sort of make that happen, but I chose not to show that as an example because it was largely terrible to read and would not make sense for right now. So this is how our base class works. We have an ID, it gives us an ID, a created date, and an updated date. So those three attributes are then given to all of the subclasses. And that's the reason we have this base class, so we can share that behavior of having a created date and an updated date in all of our subclasses. So the first subclass we're going to go and look at is actually going to be menu item, because it is the smallest and simplest class. Actually, I may have lied. We're going to start with menu. Menu is the smallest one. And we'll ignore toString for now.
So if you remember the relationships of our class, as I talked about then, we have a restaurant class, a menu class, and a menu item class. We're going to cover the menu class first. It inherits from base class, that class that we just went over. Feel free to interrupt or pose questions at any time if I'm talking too fast or covering too much. These three examples where we're going to get a lot more into the meat of the object inheritance and sharing values. So menu, it inherits from base class. That means that it gets an ID, created date, and updated date automatically. Now menu, as we mentioned, has many menu items. So it has a public list of menu items called items. It has a getter and a private setter because we do not want to allow people to then just go and willy-nilly set that entire list. And what happens when we instantiate? So we have this basic constructor for a menu. It goes and sets the items to a new empty list of menu items. So we'll now have a list of size 0 of menu items. We won't have any, but we will have an initialized list. And it does this colon base. And that then calls the default constructor that we created in base class. So we can go here. And it goes and calls. And we can actually, depending on your editor you're using, you should be able to peek at the definition. So we can see that base here, that's the base class. It assigns the ID, and we get created. So that's happening, and then we go and set the items here. Now what we do for menus, it mentioned we need to be able to add and remove items from our menu. So we have an add menu item, which takes a menu item, as you might have expected. That's that item. It calls update made. This reference and call to update made is what's automatically updating the menu every time we add an item to it. It's why over here, the updated time on the menu is the furthest out, minus restaurant. Because the restaurant got updated after the menu got updated. Because the menu belonging to the restaurant was updated. But if you notice, the created time is, if you look at the microseconds at the end, it's pretty far ahead of the updated time. And that's because each time we go and add a menu item, we tell it that an update was made. That calls the base class method because it inherits it. And because this is an inherited method, you do not need to call base.updateMade because you are automatically inheriting that behavior because it's not an overridable or constructor. So you automatically get to call it directly. It's a direct method on your class because you've inherited from the base. Now for items, we then call our items list .add like we have been for many of the items. We then have a remove menu item, which you pass the item in, says that an update has been made, and then we go and remove that item from the list. You can tell here 0 references. I'm not actually calling it, but if you wanted to call it, you could. It would remove the item from the menu. Then the other option that we wanted to do is mark that a menu item is no longer new. The reason this behavior is on the menu and not the menu item is because a menu gets to decide if it considers a menu item new to itself. Because a menu has many menu items, it gets to decide for the items that it's holding whether or not they are new. So if you think about that from more of a business standpoint, I could go and print 10 menus for my restaurant, and I'm going to decide when I count items on my menu as new. So I might count them if they've been added to the menu in the last 30 days. I'll count them as new. So for instance, McDonald's adds the McRib every now and again. If they had a catalog of menu items, the McRib would have been on it for 25 or 30 years. But it's not always on the current menu. So they re-add it whenever the cost of pork actually goes down is when they add it. If you're really curious about when the McRib goes back on the menu. So that's an example of why the menu gets to decide whether or not a menu item is new, and they mark it as sort of new each time it comes out, when they add that McRib to their menu. And then we override toString, and we'll talk about that in a minute. Any questions on this menu class? I need to cover menu item before I can cover what's in toString, because toString of the menu prints out all the menu items. All right, we will talk about the restaurant class. So what was not necessarily in your solutions, it did not mention creating a restaurant class. It mentioned having a menu and menu items, but to be practical, a menu isn't just going to live out on its own in the wild, just sitting in the street. It's going to belong to a restaurant. It's also another way to reference a relationship. In a class hierarchy, you can say a menu belongs to a restaurant. That is analogous to saying a restaurant has a menu. So our restaurant has a name, an address, a description, and a history. And it has a bunch of menus. Because restaurants often do have multiple menus. You'll have breakfast menu, brunch menu, lunch menu, dinner menu, Valentine's Day menu. Sort of depends, time of year. Restaurants will have a lot of menus. Now, because I prefer to access things through attributes, properties, as they're called in C#, find that easier, I'm overriding a lot of getters and setters here. And the only thing that's really happening, each one of these getters just returns the private variable, and the only reason I have the private variable for the both of these is because I'm calling update made each time it gets set, which ensures anytime we change the name or the address of our restaurant, we say that the restaurant has been updated. And we're keeping track of that because one of the requirements was we wanted some way within our program to be able to indicate the restaurant had been updated. In the same way, we want to be able to indicate when the menu had been updated. So if we built this out to be a really large program, did a bunch of other things, something you might care about when you update a restaurant, you could have users that are subscribed to multiple restaurants, and you could have reviews as well of those restaurants. And someone might care, oh, a review was updated associated with that restaurant, which then would mean the restaurant was updated. So then a user could get an automated email that said, oh, they've gone and added 10 reviews. A system that works very similar to that, if you are subscribed to Glassdoor, reviews of any company you're sort of subscribed to on Glassdoor, you get auto-generated emails each time a certain quorum of updates has been made to a company. So in the same way, after a certain number of updates to a restaurant, you could email your users, oh, this restaurant's been updated with all these other pieces. So that's why keeping track of updated dates can be useful, and that's why we're updating the updated date of a restaurant each time we set one of these attributes. So it's the same for name, same for address, same for description, same for history. The next up is a private variable of menus, which is a dictionary of strings to menus. The strings are the keys. So in this case, my thought here, And the reason I'm using the dictionary to hold all the menus is that your menus will effectively have a name and they will be a menu. Now I've done the same thing, making this a private setter so that anyone else sort of writing within your software system cannot go and delete all the menus at once by accident on your restaurant. That is a big reason on why you make collections of data private on your classes, so that someone does not accident go and delete all the collections from your object. So in this case, delete all the menus from a restaurant that we painstakingly spent hours creating all the menus and adding them. Now I've gone and created a whole mess of constructors. And this is a fairly common pattern in a lot of object-oriented programming languages. You sort of have your most obnoxious, if you want to say that, or most verbose constructor, which allows whomever is creating a restaurant class to give the name, the description, the history, and the address of the restaurant when they create it. So this is our most basic constructor, not our most verbose constructor. And at the end of it, it goes over here, and it explicitly states it's going to call the base constructor of its parent class, which in this case is the base class that we made. All of our classes are going to level or verbose constructor are all going to call the base constructor. So their parent class is constructor. And what happens is name gets set to whatever name is passed in, and so on for all of these variables, the restaurant. And then menus creates an empty dictionary. And that is very important. If you do not initialize your collections in your constructors, your classes will basically explode at runtime when people try to interact with them. Because if you try to say restaurant.menus, you try to iterate over that and it hasn't been initialized, you will hit a runtime exception of not being able to iterate over null, because the default value for an uninitialized object is null. So you have to be careful and make sure that you're initializing all of your collections whenever you are creating your classes and your constructors. Now I've gone and created all of the sort of simpler constructors as well. So the next one doesn't take history, the one after that. So this one right here on line 55 does not pass an address. And then as we go to the one below that, it doesn't pass in history. And as we go to the one below that, it doesn't pass description. And then if you notice, there are no more constructors defined at that point, which means no matter what, a restaurant must have a name. It will sort of catch on as it goes up the chain. You can see it to the right. Scroll a little bit, so a little easier to view. In this first case, we do the colon this. This refers to the current class. So in our case, it will be the restaurant class. This, with the parentheses, means it's going to call the constructor that takes the arguments of string and then string, which will be the one right above, which is string name, string description. We are passing an empty string by default. So then no description is given. So for description, we do the same thing. We call the constructor of our current class that takes a string, a string, and a string, which for our class is a name, description, and history. And then finally that goes and calls up again. Take string, 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 which is 4 strings, which is the verbose constructor that we have at the top, which is name, description, history, and address. The sort of key takeaway here is that I've, starting from top to most sort of generous constructor, the one that requires the least arguments, I'm passing default values to the next more verbose constructor as you go up possible constructors that you could use. The key takeaway here on what I'm doing is I'm defaulting them all to be an empty string. So if you just call the constructor you pass your name to, you're not going to have a description, a history, or an address for your restaurant. Cool. Just have a name. So now what we do here is we have the ability to add and remove menus, as was a desire. If you have a restaurant, you need to be able to give menus to it. In the same way that menus can add menu items, restaurants can add menus to them. We call update made, much like we did before. And then we're using our private variable to then go and add the name that's passed in and the menu. And we can also remove a menu either by the string name or by the menu itself. This is far less efficient because you have to go and iterate over every item in the menu in order to delete it by value. Anytime you try to delete a part of a dictionary, so if we had a dictionary that had menus for breakfast, lunch, and dinner, and you tried to delete it by not the key, but the value of the dictionary, that will always take the longest possible time because you have to iterate over every value in your dictionary. I mainly wrote this so that you could see what it is like. You most often should not delete keys from a dictionary based on the values. But if you wanted to, this is a way to do it. Then toString, I will actually show this one because we don't need any more information than the fact that we have a menu. So what we end up doing is we're using string builder. And the reason I'm using string builder is so that it will be a little bit more efficient when it's making all of that text come together to go and spit out in the end that whole wall of text that we see here of our menu. So what happens is we go and we get each one of the menus by key, and then we print out the entire menu. So you can see up here, I haven't shown you how I'm creating these yet, but it's the lunch menu, and then it prints out the menu. The next thing that I'm doing is a built-in helper function on the string class. So the built-in string in C# is a class, and it has a static method called isNull or white space, which checks to see if the string passed in is null or white space string. If it is, we go and print out the menu without any history, or if it's not, we go and we print it out with history appended at the end. So it goes name, address, description, the menus that we went and smashed together up here, and then finally, history at the end if it exists. So this is another case of doing what's called a guard clause and returning immediately if you're able to. And then if you were curious, this is the show identities. So that thing that's actually going and printing out all of the identities of our objects is printing them all out. Does the string builder again, we go over each one of the menus. We go and add the menu to it on the menu, which equates to this line. And then for every menu item, we go and call menu item.identity. And we know that all of our classes menu item, menu, and restaurant have an identity because they all inherit from base class, the one we created at the very beginning. So then menu identities, for each one of the menus that exists, I go and append 2 blank lines, which doesn't actually work because I'm not passing a string, so it's not doing anything. And then finally, what happens here is I print the identity of the restaurant class. So this is using the identity that will go and print out for the restaurant class. And then menu identities is the string builder that we've gone and created here. And that's what results in our printout of sort of our debugging information. Any questions? So menu item is a little bit more exciting. This is where I started to use some more type validation. So validation within your classes, because when you create data in a software system, you don't want to allow arbitrary data most of the time. So the first 2 things declared in the menu item class are 2 static lists of strings. What you would actually use in a realistic software system is you would use what's called an enumeration type. We haven't covered that yet, but if you want to Google it, what you would use instead of this list of strings is called an enumeration type. C# has them, Java has them. A lot of languages have them or a similar concept. However, for our menu item class, there are only certain categories we will allow a menu item to exist in, and there are only 2 types. If you can think of more, feel free to update it. You can send pull requests, they're welcome. We only have certain categories, which is appetizer, entree, side, dessert, and a drink. And then we have types of beverage and food. Because there are beverages that some people consider appetizers or desserts. So you could fall into potentially different categories depending on food or beverage. Next, we have the price, name, and description. Those are just getters and setters, as you would sort of expect. Price is a decimal. String type is a private string. This is where some of the validation-ish comes in. I do the same thing in type and category. If you attempt to set type or category to a value that is not one of the ones that we allow, we automatically choose for you. In most real software, what you would do there is what's called raising an exception, and then you would inform the end user, hey, you chose something that's not valid. But we haven't covered exception handling yet in C#, so what we're going to do is force it to be food if someone attempts to create one that doesn't have that value, and for category, we're going to make it be an entree. And then next up, we have the Boolean is new, and anytime it gets updated, we call update made, which we should actually be doing that for category and type as well. I've neglected it in a lot of spots to make it easier to go over the code, but anywhere you're setting variables, the setters should be calling that update made. So in the same way for restaurant, that we had a very verbose constructor that then went to base and kept calling its way up. We do the same thing with menu item. Menu item, however, requires a minimum of 2 arguments, being the price of that menu item and its name. How my menu item deviates from sort of the, quote, required menu item that was in the example is oftentimes when you look at a menu, you see a name like Alaskan crab salad, and then it goes and has a big long description of what's actually in the salad. So you would have a name and description. Some of them don't have descriptions, and that's when I don't know what I'm eating, and I guess. So this right here, this override of toString, is why you do not see in any of these an actual description, because all I'm doing is printing the name and then the price. Then there is no description here. So never actually hits that because I'm not passing a description, but that's why the is null or white space check is in place. Finally, what actually gets this program to run and work and show you all of that is a large piece here that is taking advantage of using some of the encapsulation ideas that we've talked that have been mentioned. Encapsulation being keeping behavior specific to your class and only a class that cares about it. And what we do here is we create a bunch of string builders for the appetizer section, the entree, side builder, for the sides, desserts, drinks, and beverages. So we have each one of those sections. Oh, nothing got marked in the. Hopefully we get a little better. I'm randomly generating 20. So what happens is, for a given menu, we go over each one of the menu items, and we check if the category is equal to each one of those categories that we put in our menu items. This is an example. So an example of why you would use something like an enumeration type is so you don't have a bunch of these what are called magic string checks in your code. Because if we were to change entree to have little accents on the E's or whatever, it would completely break our program. So you could use constants as well, but that's why you generally don't just use random strings throughout your programs, because it makes them very brittle to breaking later. What we do here is we go and add all of our items to each one of our specific builders. We have a little helper method here called makeItem. And this is an example of where encapsulation is occurring. Because if you notice, right here, the toString of item knows how to represent itself. And when it represents itself, it represents it by saying, I have a name and I have a price. There's nothing on there that says new, because an item is not concerned about saying whether or not it's new. That's something a menu cares about. A menu cares about if an item is new. Which is why we have this makeItem method, which is private. So this is an example of encapsulation, that concept. The makeItem is a private method because the only thing that cares about it is when we print out a menu. And all that it does is it says, if the item is new, we append that -- new to it. Otherwise, just go and return the item as is. And that's why we have cases where it's showing -- new. So we go over each one of the items in our list of items, and we put them in their section. Right here is where we're actually going and taking advantage of if it's a drink or if it is a beverage, which this is where you can then allow some overlap, and it's why each one of these is an if statement and not an else if. Various menus, some items listed as appetizers are later in the menu also listed as entrees or listed as desserts. That's why each one of these is an if statement, because you could be listed in two places on the same menu. which means later we would likely make an update to our item that would allow it to belong to multiple categories. So then what we do here, so at the very end what we do is we return our appetizers, then our entrees, our sides, desserts, and our drinks. We use encapsulation again with a make section method. And that's why each one of these has a nice little hyphen, hyphen, section name, hyphen, hyphen, and then all the items in the section, and so on. That's achieved because we encapsulate that common behavior that we want when we print. And we give it a name, 2 new line characters, the entire section, which is our string builder. We take a string builder in. And then we go and print out the 3 new lines. And that is how this guy goes and prints out each one of the menus. And the studio for tonight, sorry, I have to switch immediately because you have negative 30 seconds. Studio for this evening is to create a quiz. So people can, on the command line, answer questions to a quiz. So you've likely taken quizzes. There are multiple choice options. There are checkboxes, and there are true and false. But those are all questions. So likely you'll want some kind of base class, very similar to what I've done in the restaurant example, that will share behavior between all of your possible types of questions. And you'll want to design it out and implement it. So design and implementation, and do be sure to work with others. The code, all this code is linked to from tonight's assignment. So I already have the link in there. You can go and look at the code that is here if you want to look at an example. I didn't show you what was happening in program.cs. The main thing you'll care about is where it's asking you to read in people's answers for quiz answers. It is right here on line 28. I'm doing a read line from the console. Assigning it to show more, and that's how I'm not actually doing anything other than checking that something was typed in. That's where you would check for someone's answer to a question. So that's an example of how you can read user input to answer the questions, for them to be able to answer questions. So if you want to see an example of that, it is in the program file from the notes that I've just covered. The link is in the assignment for tonight. Not the assignment, but what we covered tonight. And that is all. You probably do have a lot of questions, and I'm happy to wander around and answer them. But now you get to stand up and move around. Trade places. Get you some music. Hola. Hello, here we go. And, oh, they lost their music. Now it's just for me.